Hello everyone, today we'll be diving into the world of integrity, rules, and constraints in relational databases. Let's explore how these principles ensure accuracy and consistency. In our first slide, we introduce the concept of constraints. These are crucial features that enforce rules on attributes or tables within a relational database, ensuring the integrity of the data stored. Domain integrity, which restricts attribute values to maintain data consistency. While domain constraints are essential, they may not cover all scenarios, leading us to a more specific integrity and constraints. Entity integrity, our next topic, mandates the presence of primary key in every table. This ensures each row in the table can be uniquely identified, preventing any data anomalies. Referential integrity ensures consistency between related tables by enforcing rules on foreign keys. This prevents orphan records and maintains the integrity of the database. Enterprise constraints are user-defined rules that go beyond individual tables, encompassing multiple entities. These constraints are based on specific business logic and are crucial for the database integrity. Business rules, on the other hand, are gathered from users during the requirements gathering phase. They guide the design of the database, ensuring it aligns with user needs and expectations. Understanding cardinality and connectivity is essential for designing effective database relationships. Cardinality describes the number of occurrences between entities, while connectivity defines how they are connected. Now, do you think you could tell me which one is connectivity and which one is cardinality, the top or the bottom? If you guessed that connectivity was at the top, then you'd be correct, and cardinality is at the bottom. Now, I want to show you another relationship, and what kind of relationship would you call this one? If you said 1-to-1, then you were correct. Now, if I show you another one, now what would you call this one? This is a one-to-many relationship and requiring both of them to not have a null value because they are each mandatory and then one-to-many. Relationship types, such as identifying and non-identifying, play a significant role in database design. Identifying relationships contain foreign keys in the primary key, while non-identifying relationships do not. In optional relationships, the foreign key can be null, and the parent table may not require a corresponding child table occurrence. This flexibility is crucial in certain scenarios. And as you can see in here, this one shows that a customer can have many orders, but the customer does not need to have an order to be a customer. And then on here it shows one order must be associated with a maximum of one customer. And then on here, since it's mandatory, it says an order record must have a valid customer and must not be null. Mandatory relationships, on the other hand, ensure that one entity occurrence requires a corresponding occurrence. This maintains data integrity and enforces one-to-one or one-to-many relationships. As shown in the example, an employee is associated with a minimum of one spouse, while also an employee in the employee table must appear in the spouse table at least once. And then a spouse record must contain a minimum of one valid employee ID. Here's a small summary of the course. Please give me any tips or corrections whenever you view this video. Thank you.